Today we'll be looking at the area of regular pentagons. The reason we kind of split it up between area of regular polygons, which we did yesterday, we were familiar with that and we used special right triangles. And then today, the area of regular pentagons, we're actually going to use a little bit of trig to figure this one out. So, if you will, grab a pen or a pencil and let's get these notes started so we can get on to the assignment. So when we're looking at a pentagon, there's the same qualities in any regular polygon. They have sides, they have a radius, they have the apothem, and they have the center. Those have those qualities apply for every polygon that you have. So what we need to look at is we need to look at what this angle is right here. On a regular triangle, we know that that is 30. On a regular hexagon, we know it's 60 because of the breakdown of the angles. So let's take a look at what that angle might be. When we're looking at a regular pentagon, we have 5 angles that make up the pentagon and 5 sides. If you remember from earlier this year, we can find what each interior angle is by taking a formula, 180 times n minus 2, and then dividing by n, where n is the number of sides of the polygon. If you look here, we have a pentagon, so we have 5 sides. So for n, we're going to substitute in 5. 180 times 5 minus 2, all divided by 5. So that's 180 times 3 divided by 5, which is 540 divided by 5, which is 108. So each angle in a pentagon is 108 degrees. Then we know from our characteristics that this is a radius, and the radius bisects every angle. So that means this angle right here is cut in half. If that measure is 108 and it's cut in half, each angle then is 54 degrees. That provides a little bit of trickiness to us for us looking at the area of a regular pentagon, because now we have a triangle that we're going to have to use trig to figure out what the apothem is, or if we're given the apothem, what the side length is. So let's look at a few examples of seeing how to do that. Example 1, it says that you have a pentagon. I went ahead and gave you the angle so it didn't make you figure out the angle. But you have a side length of 35. Okay, so from our characteristics of polygons, we know that the radius cuts the angle in half, and we know that the apothem divides the side in half. So if the apothem divides this side in half, this side right here is half of 35, which is 17.5. So now we have a triangle. I'm going to draw it out. But you have 54 degrees right here, your right angle's right here, and this is 17.5. We need to label our triangle so that we know we have the hypotenuse. That's the angle we're working with. This is the opposite, which is what we're looking for, and then this is our adjacent. So if you remember from last week or 2 weeks ago, we're working with the adjacent and the apothem, so that means we're going to be working with tangent. We're looking for the apothem. So to find what the apothem is, to find that x value, we're going to say the tangent of 54 degrees is equal to your opposite, which is x, over your adjacent, which is 17.5. If you remember, to find out what that opposite is, we're going to multiply by 17.5 to both sides. So in your calculator, and I know I don't have it up for you right here, but in your calculator, I'm going to need you to type in 17.5 times the tangent of 54. Please make sure that your calculator is set to degree mode. Alright, so we're going to do 17.5 times the tangent of 54, which gives us 24.087 is equal to x. So that's our apothem, 24.087. Okay, so now that we've worked that out, I'm going to get a new screen so we can find the area of this polygon. So while I pull up the picture, we know that this is, this is 24.087. That's our apothem, 24.087. Now we need to find our perimeter. We have 35 as the side length, and we have 5 of those sides. That's 175 centimeters. So now what we can do is just plug it into our formula, 1/2 of the apothem times the perimeter. So we're going to say 1/2 of 24.087 times 175. Which is 2,107.61. And we're going to round to the nearest hundredth. So our area of this pentagon is 2,107.61 centimeters squared. Let's look at our next example. You're given the apothem, which is 13. We need to find the side length. We need to find this right here. Okay, so we're going to pull out this triangle, label it, and see what we have. We want to find this. So you have your hypotenuse. Label the, or mark the angle you're working with. This is the opposite. This is the adjacent. That's what we're going to work with. So again, we're using tangent. The tangent of 54 is equal to your opposite, which is 13, over your adjacent, which is x. We don't know it. If you remember our trick from last week, when we have the tangent of 54 and then our x is on the bottom, we switch these two. So we're going to say x is equal to 13 divided by the tangent of 54. If you put that in your calculator, you get x is equal to 9.445. But that's just this little segment right here, 9.445. We need to know the whole side. Again, if you remember the characteristics of polygons and your characteristics of the apothem is bisecting the side. And so if we just multiply by 2, we get the whole side length. That's 18.89. So our side length is 18.89. So let's go ahead and pull up another screen so we can find the area of this regular polygon. All right, we said the side is 18.89. Our apothem is 13. Our perimeter we have to find. The whole side is 18.89. Then we multiply by 5 because we have 5 sides. And that's 94.45 centimeters. Now all we have to do is plug it in to our formula. 1/2 of the apothem, which is 13, times the perimeter, which is 94.45. You plug that in, and you get the area of that regular pentagon is 613.93 centimeters squared. So the area of regular pentagons is a little bit different because we do use trig, but just remember, start by finding the triangle by using trig, then find your area. Okay? Good luck, and if you have any questions, please make sure that you ask.